Go. Okay, so oftentimes I start off with a little section on vocabulary and concepts. So let's go over, this is like a practice test from a previous year. I have 6 questions here. Who wants to define voltage? Potential difference would not be an acceptable definition because if I didn't know what potential difference meant, I wouldn't know what that meant. So can you do it more in layperson's terms? It's like, explain it to somebody who just finished calculus but hasn't taken any kind of electronics courses. See, you can't do it. Actually, you can pan the camera to the, not just focus on me. So, anybody else want to try? Definition of voltage. I know, it's so basic. Like, we're working with voltages all the time in these problems, but can you really explain what it is? Kyle, do you want to try? No? You don't even want to try? Okay. Never mind. Actually, I should have asked you if it's okay to film. It's just for your classmates. Do you care? Does anybody care? Do you not care? Is anybody going to answer me? Boy, it's just like being on the forums. All right. Okay. The definition of voltage. First of all, you can't talk about voltage unless you talk about 2 specific points that you're considering the voltage between. All right? So the definition of voltage is the amount of work that it takes to move a charge from one point in space to another point in space. That's the definition. The amount of work, the amount of work it takes to move a charge from point A to point B. So the voltage of A with respect to B would be units of volts, but a volt would be a joule, an amount of energy per coulomb. Okay, so it's going to take whatever amount of work it's going to take. But a volt is a joule per coulomb because it's looking at how much work or energy it's going to take to move a charge from point A to point B. So that's the definition of voltage. So why don't we see a subscript on most of our voltage symbols? You know, when we identify voltage, like here, well, here I do have a subscript too, but that's just because there's other voltages in the problem. But I'm showing this voltage between point A and B. If we talk about the voltage across an element, then you're talking about the terminals on either side. So you are talking about points in space that you're measuring voltage across. And so it's always important to keep that in mind. All right. Number 2, what's a circuit element? Anybody want to try? Okay. A circuit element is just any device with a terminal on either side. Really, that's all it is. And it's just, I think when I first introduced it, I just called it a blob. It's just something with 2 terminals on either side. Now, what we're going to do with that something is model a relationship between the voltage across it, right? And by across it, I mean from the terminal on one side to the terminal on the other side, and the current through it. Okay? So the relationship between this voltage across the element and the current through it defines what kind of circuit element it is. So we know that if the circuit element is a resistor, this voltage-current relationship looks like that, V equals IR. So that's just, one example of a circuit element. All right. So the important idea behind circuit element is that you have some device with 2 terminals on either side, and what you want to do is figure out the relationship between the voltage across it and the current through it. Okay, what's an active circuit element? This is why why you took an online class, right? So you wouldn't have to participate in class discussions. So, should I just go and tell you? Okay. So an active circuit element, there's a couple ways to think about it. There's like a qualitative way and a quantitative way. So qualitatively, it just means that it's a device where it's a circuit element that's capable of delivering energy to the rest of the circuit, or it's capable of doing work. So that's the concept behind it. The math behind it looks like this. So I'm defining that the work of the element, or the energy, from, okay, minus infinity is kind of a strange thing, but think about it as from the beginning to now. T is an instant of time, which would probably be just some time that we're interested in, so I'll just call it now. So from the beginning till now, the work done from beginning to now for an active circuit element has to be bigger than or equal to 0. All right? You know, we can also think of this beginning as when the thing was manufactured. Or we might want to think about it as some instant of time where we start our clock ticking. But at that instant, it hasn't done anything yet. So there's been no energy or work delivered or absorbed or anything like that. So this is a little bit of a strange symbol mathematically, but that's the idea behind it. Okay, so an active element has this relationship. Okay, and let's look a little bit more in detail about what this thing is. This is the work done. And we know that that it's equal to the integral of the power over the time interval. Okay, so the time interval again is from the beginning till now, and power, remember what power is? It's the current times the voltage. Okay, so in that circuit element, whatever that element is, whatever blob that circuit element is, we have a voltage across it, we have a current going through it, and so the power is equal to the current times the voltage. Now, is this power delivered to the circuit, or is it absorbed, given the picture that I have here? It's absorbed by definition, right? By what we call the passive sign convention. The definition of power absorbed is that the current is going into the positive terminal of the voltage. Okay, so that's an active element. What's an independent source? Well, it's kind of the opposite of a dependent source. And what?
Supplies power.
They both supply power. Both dependent sources and independent sources supply power. So I'm looking for more detail, more defining.
Dependent source supply power based on a condition.
What is based on a condition?
Dependent source is supplied.
That's right. A dependent source depends on a current or a voltage somewhere in the circuit. An independent source then is independent of any other current or voltage in the circuit. Okay, so it's independent . Okay, so, we've been talking about voltage sources, and we've also got some current sources. So a voltage source, a current source. And, these are hooked up to series of resistors or parallel resistors with other things, dependent sources, lots of other things. These could be hooked up to anything. But whatever it's hooked up to, the voltage that this delivers will be independent of any other current or voltage that it's hooked up to. And similarly for this. And a dependent source, we know that it can depend. It'll probably be equal to some current or voltage in the circuit times a constant. So we've seen that. here's the thing that I wanted to really emphasize in asking you this. What then is the difference between an independent source and an ideal source? Because a dependent source is also ideal. I love that look. Should have caught that on camera when I said that. I said that a dependent source is also ideal, and he went. So what's an ideal source? Okay, here's what it is. We have, consider these one at a time. Okay, so don't think about that one. You're just looking at this one. So this is a voltage source. It's going to deliver the voltage that it says that it's going to deliver, no matter what else is going on in the circuit, because it's an independent source. But it will also deliver that no matter what the current is that's going through here. Now you look at this and you kind of probably in your mind, you see a current going out like that, right? But really, it doesn't have to be that way. This current might be going this way. It really depends what it's hooked up to. If the current's going this way, then this voltage source will be charging. If you think of it as a battery, it's going to be charging. So it can have a current going into it like that. But the point is that no matter, and the current could be zero. So it could be anything. It could be zero, it could be going this way, it could be going this way, it could be a really big current, it could be a small current. If it's ideal, then the voltage will be whatever it says it is, no matter what. Now, of course, that's not true in real life. But we're not in real life here. We are in our ideal world where we model this ideal voltage source as delivering this voltage, whatever we say it is, no matter what the current is that's going through it. So that's what we mean by ideal, and that's also true for a dependent source. The dependent source will deliver what it says it's delivering, like 10 V1, where V1 is some voltage somewhere over there. It delivers this no matter what the current is through it. So that's what we mean by ideal. And that's different than independent. And the way I like to think about this is that an independent source is an ideal source, so it's independent, in this case, if it's a voltage source, it's independent of any current through it, but it's also independent of any current or voltage anywhere else. So it's like it's one step up from ideal. And then a dependent source is ideal, it's independent of the current through it, if it's a dependent voltage source, but, of course, it might be dependent on a voltage or current somewhere else. Okay, so we're going to pause here for a sec.